self.label.setText method, then pass in some new text to display. We're saying hello, but when we click the button, let's say goodbye. So now, when I click the button, we will change the text on a separate widget, my label, which now says goodbye. So with buttons, you need a signal that's connected to a slot. The signal is an event. The slot is an action that this widget is going to take when this signal occurs. And well, everybody, that is an introduction to push buttons in PyQt5. Hey, so today I gotta explain checkboxes in PyQt5. To work with checkboxes, we will need the following import. From the module of widgets from PyQt5, import Q checkbox. To work with different states, we will also need the following import from PyQt5.qtCore import Qt. This module of Qt Core, it contains non-GUI classes relevant to PyQt5 applications. So be sure that you get this import as well. To create a checkbox, I will create this within the constructor of my main window. We will create a checkbox with self, the name of the checkbox, which I will name checkbox, equals, call the constructor of the QCheckbox class. The first argument is going to be the text of the checkbox. What do you want the checkbox to say? Let's ask, do you like food? The second argument is the parent widget, where we will be adding this checkbox. Let's say self. Self will apply to this window. We could use a layout manager, but I want to keep this lesson as simple as possible. We're just going to focus on checkboxes and their functionality. So we should have a checkbox. However, we can barely see it. The font is really small. I have a method to initialize the user interface. That's where we'll set the style sheet and the geometry of our checkbox. Let's set the style sheet. Self dot the name of the checkbox, checkbox dot set style sheet method. Then we can pass in some CSS-like properties. Let's set the font size to be 30 pixels. And I will pick a font family. Font family Arial. Oh, and we should change the geometry of the label. It's getting cut off. Self dot the name of the checkbox, which is checkbox. Let's set the geometry. Pass in some X and Y coordinates for the placement, as well as a width and a height. I will pick 500 and 100. Maybe I'll move it a little more to the right by 10 pixels. That's pretty good. Our checkbox has an initial state. It's normally unchecked. That's the default behavior, but we could set that to be checked with the following method when the window loads. Let's take our checkbox, self.checkbox, call the setChecked method, then pass in true. So then when the window loads, the checkbox is already checked. But let's keep that as false. Now this checkbox, it doesn't do anything when I check it. Let's add some functionality. We'll take our checkbox, connect a signal to a slot. The slot can be a function or a method. Let's define a method within our main window class. Let's name this method checkbox changed. We will call this method when the state of our checkbox changes. There is one parameter besides self, a state. Now, the state parameter is going to be provided to us when we interact with our checkbox. When we check the checkbox, let's print something, like a test message. You like food. We have to connect a signal of state changed to a slot of checkbox changed. We will take self dot the name of the checkbox, which is checkbox. The signal will be state changed. To connect a slot to a signal, we use the connect method. Then pass in a function or method name. So we are working with methods. This method belongs to the window class. We'll prefix the method name with self. Self.checkboxChanged. So when I run this program, when I check the checkbox, we execute this method. You like food. Now when I uncheck it, I instead would like to display you do not like food. So that's where our state is going to come in. I'm going to print our state just to see what it is. Our state is going to be a value. When we check the checkbox, our state has a value of 2. When we uncheck it, it has a value of 0. 0 means unchecked, 2 means checked. There's also 1 for partially checked, but that's not going to be relevant to this topic. So 0 or 2. We could add an if statement such as if state is equal to 2, then print you like food. However, that's not really readable. Other developers looking over your code aren't going to understand what 2 is by looking at it. Instead, let's use the following. We will access the class of Qt. There's a built-in constant of checked. This also equals 2, but it's more readable. It's a constant. So if state is equal to Qt checked, print you like food. I will check the checkbox, you like food. When I uncheck it, nothing happens. Let's add an else statement. Else, let's print you do not like food. So then, when I check the checkbox, we print you like food. When I uncheck it, we print you do not like food. You like food, you do not like food. You like food, you do not like food. Alright everybody, so that is an introduction to checkboxes in PyQt5. Alright, let's do this thing. Today I gotta talk about radio buttons in PyQt5. To work with radio buttons, we will need the following imports. From the module of Qt widgets, we will need the class of Q radio button, as well as Q button group, to group together different buttons. Let's create 3 radio buttons. Within the constructor of my main window, we will construct 3 radio buttons. For the first radio button, this will be named radio1. We will call the constructor of the class QRadioButton. Then we can pass in some text. What is the radio button going to say? Let's say that we're working with payment options. Let's say Visa for the first option. Then for the second argument, I will pass in self. We will add this radio button directly to our window. That would be self. Let's create 2 more additional radio buttons. Radio 2 and Radio 3. The text of radio button 2 will be MasterCard, and 3 will be a gift card. We are selecting different payment options. We need to set the geometry of these radio buttons because we're not using a layout manager. I have a method to initialize my user interface. This is where I will set the geometry of my radio buttons. So let's say self.radio1. We will call the setGeometry method, pass in some coordinates. 0, 0 is good. That applies to the top left corner of my window. For the width, 300, and the height, 50 is good. Let's do this with radio buttons 2 and 3. Radio 2, Radio 3. We'll just move each radio button down on the y-axis by 50 pixels each. So 50, then 100. Here are the 3 radio buttons. However, the font is kind of small, we can barely see it. So let's apply a style sheet. Here's a trick that we can do with style sheets. We can apply multiple CSS-like properties to an entire group of widgets, rather than having to type them and apply them individually. We will select our window of self, set the style sheet of our window with the setStyleSheet method. We will add a selector. The selector is going to be the name of the widget. QRadioButton in this case, then add a set of curly braces. We can apply CSS-like properties to an entire group of widgets this way. So let's set the font size of all radio buttons to be 40 pixels. Better. Let's set the font family to be Arial. Then I will add a little bit of padding around each radio button. Padding 10 pixels. That's pretty good. So with radio buttons, we can only select one from any one radio button group. If I was making a payment, I can't pay with a Visa and a MasterCard at the same time. I can only select one option. That's the point of radio buttons. We're limited to just one option. With the default behavior of PyQt5, all radio buttons, unless explicitly stated, are all part of the same group. To demonstrate that, let's create two additional radio buttons, Radio 4 and Radio 5. Radio button 4 will be for a payment method rather than a payment type. For example, we could say we're paying in store. Radio button 5 will be we're paying online. Radio buttons 1 through 3 will be for the payment type. Radio buttons 4 and 5 will be for the payment method. We're either paying in store or we're ordering something online. We do need to set the geometry for these two radio buttons. I'll just copy these two lines, add Radio 4, Radio 5. We'll set the y-coordinate of 4 to be 150 and 5 to be 200. All radio buttons will be within the same button group. If I was to select In Store, we deselect one of these options. What I would like is one option from this first group and another option from this other group. These buttons are all in the same group. I can only select one. If I would like to pay with a Visa in store, and I click the In Store radio button, we unselect the radio button for Visa. I would like these radio buttons within different groups. We need to create two different groups and add them accordingly. Here's how. Within our constructor, we will access self, declare a button group, let's name it button group 1 for simplicity, equals, call the constructor of the class QButtonGroup, then pass in self to set the parent widget to be the window. Then we will create button group 2. We're going to access self, select the radio button group, button group 1, call the add button method, then pass in a radio button, self.radio1, then we'll add radio 2 and radio 3. We'll select button group 2 this time, button group 2, add radio button 4 and radio button 5. The first three radio buttons are within the same group. Radio buttons 4 and 5 are within a different group. We can only select one radio button from any one radio button group. Maybe I would like to pay with a Visa card in store, or a MasterCard online, or a gift card in store. These radio buttons are within different button groups. We're limited to one selection in any one radio button group. When we select these radio buttons, they don't quite do anything. For each radio button, we have to connect a signal to a slot. Here's how. Let's define a method of radio button changed. There will be no parameters besides self. Temporarily, I'll write pass. We'll fill this in a moment. We will take each radio button. Let's start with radio 1. Radio 1, the signal will be toggled. When this radio button is toggled, we will connect a slot. We will pass in a function or a method, self.radioButtonChanged. Then we will do this with the other radio buttons. 1 through 5. Let's print a test message. You selected something. Just to be sure that everything is working. You selected something. Okay, we know that that works currently. What we're going to need to do is get the sender widget. Which radio button sent the signal of toggled? I will create a local radio button to store that radio button. whichever one emitted the signal. We can determine that with self.sender method. The sender method is going to return the widget that sent the signal. So if we select radio button 1, our radio button will be radio button 1. If it was 5, then it's 5 in this case. Then we'll determine if our radio button is checked. Take our radio button, use the isChecked method. This will return a Boolean, true or false. If it's checked, if this returns true, then let's print the following. I'll use an F string. We will get the text of the radio button. Radio button, call the text method to return the text of the radio button. Is selected. Alright, then let's see if this works. Let's select Visa. Visa is selected. MasterCard is selected. Gift card is selected. In-store is selected. And online is selected. That's how to determine which radio button was selected. Which one is the sender? Which one sent the signal? Alright everybody, so that is an introduction to radio buttons in PyQt5. Why, hello everybody. Today I gotta explain line edit widgets in PyQt5, also known as text boxes in pretty much anything ever made ever. Why are they called line edit widgets? I really don't know. Let's begin. From the module of Qt widgets, we will import the following class of Q line edit. To create a text box, I mean a line edit widget, we are accessing our window of self. We will call this line edit widget line edit equals call the constructor of the class QLineEdit. Then we will pass in self to add this line edit widget to the window. Let's set the geometry, but we do have a text box in which we can type in stuff. I have a method to initialize the user interface. Within this method, I will access self.theLineEditWidget and set the geometry. Let's set it in the top left corner where x is 10, y is 10. Set a width, 200 is good, and a height, 40. That's not too bad. Now the text is really small. We can change that by applying a style sheet. Access our window with self, access our line edit widget, then call the set style sheet method. We can pass in some CSS-like properties, including a font size. Let's pick 25 pixels. And here's my new text box. We can read the text now. Let's also change the font family. Font family, I will pick Arial. This text box by itself, it really doesn't do anything. We need some way to get the text from the text box. Let's add a button. When we click on the button, we will get the text from the text box and do something with it, because right now it doesn't do anything. We will need to import QPushButton. Let's create one button. Self.button equals call the constructor of the class QPushButton. Let's say that this is a submit button. I will pass in a string of submit, and we are adding this button to our window. And we do need to set the geometry of the button. We're not using a layout manager right now. Access our window with self, access our button that we have previously created in our constructor, then call the setGeometry method. We'll place our button where x is 210, y is 10, the width will be 100, and the height will be 40. Not too bad. Let's change the font size of the button. I'll copy these 2 lines of code because I'm lazy. Instead of selecting our line edit widget, we will select our button. That's better. If I were to click on the button, it doesn't do anything. We'll set up the signal of clicked to connect to a method that will do something. Let's define a method of submit. We're submitting something. We're submitting the text within the text box. And for now, I'll write pass. We'll get back to this in a second. We're going to take our button, self.button. We'll connect the signal of clicked.connect method. We will connect the method of submit, self.submit. So when we click on the button, we will call this method. Let's print a test message. You clicked the button. Let's type in something, press submit, and we get our test message. You clicked the button. Let's get the text from the text box, then do something with it. Let's create a local variable of text. Text equals, now we have to get the text from our line edit widget. Self.line edit, that's the widget. To get the text, we can use the text method to return the text. Then let's print the text. I'll use an F string. We'll say hello, add a placeholder, then display the text. So now, after typing in something, why don't you type in your name? Then press submit. We will display hello, your name. You could add some placeholder text too. Let's do that here. Let's take self.lineEditWidget, set placeholder text, and let's say enter your name. When I run this program, we have some placeholder text that says enter your name. This time I will type in SpongeBob, then press submit. Hello, SpongeBob. Alright everybody, so those are line edit widgets, also commonly referred to as text boxes. And well everybody, those are line edit widgets in PyQt5. Hello everybody, so in today's video I'm going to explain setting style sheets in PyQt5. CSS means cascading style sheets. If you're not familiar with CSS, you can still follow along, but knowing CSS is helpful. As a reminder, I do have a full free course on YouTube on HTML and CSS if you would like to learn more. Let's begin. For this demonstration, we will need the following imports. We will be designing some buttons. We will import QPushButton. We'll be working with the layout manager. We will import QWidget. And for a horizontal layout manager, we will need QHBoxLayout. So import these three from the module of Qt widgets. Now in previous topics, we've set the geometry of our window. Since we're using a layout manager, we don't necessarily need that anymore, so I'm going to delete it. In the past, I have also created a method to initialize our user interface, and we are calling that within the constructor of our main window. We will create three push button widgets. Self.button1 will be the first button, equals, take our QPushButton class and call the constructor. We can add text to the button. We will pass that as an argument. Now, since we're using a layout manager, we don't need to add this button to self, our window. We don't need to do that. Let's create two more buttons. We'll have button 2 and button 3. Button 2 will say number 2, button 3 will say number 3. Now we'll create a layout manager. Under normal circumstances, we can't add a layout manager to our main window. With main window widgets, there's already a specified layout and format. We're going to add a layout manager to a central widget, and this widget will be added to the main window. Let's take care of that within our initialize user interface method. We will create a central widget equals call the constructor of QWidget. Then we will take self, that means our window, and set the central widget. Set central widget. Then pass in our central widget to set it. Then we will create a layout. We will call the constructor within the class of QHBoxLayout. Let's name this layout HBox for a horizontal box. Equals, call the constructor within this class. we will take our layout of horizontal box, then add the following widgets. Add widget self.button1. We'll do this with 2 and 3. Then the last thing we need to do is take our central widget, call the set layout method, then pass in our layout manager. And now we should have those 3 buttons. They're all arranged horizontally. Now we're going to apply some CSS-like styling using the method of setStyleSheet. Here's how. Rather than apply the CSS properties individually, such as self.button1.setStyleSheet, and in the past we've passed in individual CSS properties, we're instead going to set the style sheet of our window, self. We have a lot to write. Instead of double quotes, we're going to use triple quotes. Triple quotes are used to write very long strings in a more organized way. All of the CSS properties that we're going to write are going to be within this set of triple quotes. So let me give you a demonstration. We could individually apply CSS-like properties to each of these widgets, but we could select an entire class of widgets too. Let's select the class of QPushButton, then add a set of curly braces. The following CSS properties will apply to all QPushButton widgets. So currently, this is what we have. We'll increase the font size for every push button. So we will add the following property of font size, then set it to be 40 pixels each. Be sure to end each CSS property with a semicolon. So the font size is now 40 for every button. Let's set the font. Font, family, I will pick Arial. Let's add some padding. We can add some space around the text and the button itself. So with padding, if I was to set this to 75 pixels, we would have 75 pixels worth of space between the text and the border of the button. I would like to change the dimensions of the padding. So let's apply 15 pixels to the top and bottom of the button and 75 to the sides. That's better. Margin is the space around a button. Let's set the margin to be 25 pixels. Now the buttons are more spread out. If this was 250, they would really be spread out. That's margin. It's the space around a widget. Let's set that back to 25. I'm going to change the border. Border 3 pixels solid. This would change the border of the buttons. We now have a black border that's 3 pixels in width. If you would like to round the corners, we can use border radius. I will set that to be 15 pixels. With all the buttons, the corners are now rounded. Within our setStyleSheet method, we're applying all of these CSS-like properties to every push button. Now, what if you would like to apply CSS properties to only one widget rather than all of them? Here's how. With each of our widgets, buttons 1, 2, and 3, we need to set an object name. Let's do that before we call the setStyleSheet method. We will take our buttons, self.button1, call the setObjectName method, then pass in a name for this widget. We'll keep the name the same as button 1. So let's do this with button 2 and button 3. Button 2, button 3. Within the context of setStyleSheet, we will refer to these widgets by their object name, buttons 1, 2, and 3. And now we can select them individually. Let's say that with button 1, I would like the background color to be red. We're going to access our class of QPushButton, follow this with a £. I'd like to call it a hashtag. Then we need the object name, button 1. Button 1 refers to the widget of button 1. Again, I kept the name the same. Then we need a set of curly braces. Between the set of curly braces, we can list one or many different CSS properties. Let's change the background color. I will set it to be red. And now the background color of only that button is red, and not all of them. If I was to set the background color within the class, well then, all of them would be red. Okay, so with button 2, I'll just copy what we have and paste it. We are selecting the ID of button 2. Let's set the background color to be green. So then the background color is now green. And button 3. Button 3 will be blue. If you would like a greater variety of colors, I recommend looking up a color picker. You can just Google color picker. So if I would like a very specific shade of red, I can pick that. Let's go with that. There are a few options provided to you. You can use hex values. Now we have a very specific shade of red. You can use RGB. RGB. Enclose it within a set of parentheses, and then paste those numbers. Or my favorite, which is HSL. HSL means hue, saturation, and lightness. We will enclose our values within HSL. If you copy these values directly from Google, you would have to remove this degree symbol. I like HSL because I can also control the saturation and the lightness pretty easily. Okay, let's pick a very specific shade of green. That's good, I would say. I'll use the HSL values. HSL. Remove the degree symbol. And now we have a very specific shade of green. And blue. That's good, I would say. That's not too bad. If you're already familiar with CSS, we can apply pseudo-classes, such as when we hover over one of the buttons. Here's how. Let's copy these 3 blocks, then paste them again. We can add CSS properties when we hover over something. We have to use the hover pseudo-class. After the ID of each of our buttons, we will add :hover. We can apply the following CSS properties when we hover over the buttons. All I'm going to do is up the lightness, let's say by 20% each. Then when we hover over one of the buttons, the lightness is going to change. We apply the new CSS properties. Alright everybody, so that is a more in-depth explanation of the set style sheet method in PyQt5. Alright everybody, in today's video we're going to build a digital clock widget using Python's PyQt5 library. At the top of our Python file, we will need the following imports. Import sys. Sys means system. This module provides variables used and maintained by the Python interpreter. We would also need widgets. Widgets are the building blocks of a GUI application. From the package of PyQt5, we need to access the module of Qt widgets. Import the following: Q application, Q widget. This is a generic widget. We'll turn our digital clock into its own widget. And Q label to work with labels. We will be using a layout manager, more specifically QV box layout. There's another import we'll need too. From the package of PyQt5, access the module of Qt Core. The Qt Core module, it provides functionality not related to GUI components. This is where we'll get a timer to keep track of the time. From this module, we will import QTimer, QTime, and Qt. Qt is for alignment. We will create a class of digital clock. Instead of inheriting from the main window widget, we will inherit from the base class of QWidget. QWidget is a base class to create our own widgets. Our digital clock will be a widget. We will need a constructor, so let's define that. Define init, pass in self. If there are any arguments to send to the parent, we will call the constructor of the parent, the superclass. Super, call the init method. At the end of the constructor, what I like to do is call a method of initialize UI. Init UI. This will be a separate method. Define init UI. There are no parameters besides self. And for now, I'll write pass. It's within this method that we will be designing the layout of the digital clock. Within the constructor, that's where we will be constructing all of the different entities for the clock. At the end of my Python file, I will add the following statement. If dunder_name is equal to a string of dunder_main. This statement will be true if we are running this program directly. To create an application, we will create an app object equals, call the constructor within the class quApplication. As an argument to the constructor, we will pass in the following argument. Access the module of sys argv, which means arguments. This would apply if we're running from command prompt or terminal, but we won't be doing that in this video. But it's nice just to set it up in case we do in the future. Now, we are going to create a clock object. Clock equals, we will call the constructor of our digital clock class. There are no arguments. Now, the window doesn't appear. That's because we have to use the show method of our clock. Take our clock, call the show method. Now, it's only going to appear for a brief second. Just momentarily, I don't know if you saw that. To ensure a clean and proper exit of our application, we need to call the following method. Access our module of sys, call the exit method, then pass in the following. We will take our app object, then call the following method. exec underscore, and then a set of parentheses. It's a method. It's the execute method. It starts the main event loop of the application. It also handles events, such as key presses, mouse clicks, or other user interactions. So then, we should have a window that stays in place until we exit. Okay, now we have the base functionality all set up. We have a class of digital clock that inherits from the QWidget base class. We're not going to be using main window in this video. Within the constructor of my digital clock, I will create a label, self.time label. This will be a label that displays the time. We will call the constructor within the class QLabel. Then be sure to pass in self. We will be adding this label directly to our widget of clock. We will need a timer, self.timer equals, call the constructor of QTimer, then pass in self. We are adding the timer to the clock. Now with designing the layout of our clock, I'll handle that within the initialize user interface method. We're going to set a title for the window. Self.set window title method, pass in a string that will be used for the title of the window. Let's say digital clock. Then our window should say digital clock. Let's set the geometry of the window. Self.setGeometry. The first two arguments are going to be for the placement of the window. Where will it appear within your screen? So I'll pick something approximately in the middle for me, but feel free to change these values. Then we need a width for the window, let's say 300, and a height, 100 for the height. So my window should appear approximately in the middle of my screen. The base width is 300, the base height is 100. Now we're going to need a layout manager. I will name this layout manager VBox for a vertical box. VBox equals, call the constructor within the class QVBox. This will arrange all of our widgets vertically, but we only have one widget, a time label. So we will take our layout manager of VBox, add widget, that's a method. We will pass in self.timeLabel as an argument. We're adding our label to this layout manager of VBox. Then to set the layout, we will take self, that applies to our clock, call the set layout method, then pass in our layout manager of VBox. So currently if I run this, we don't see anything. Temporarily within our label, I will add some text just as a placeholder so we can see what we're working with. Let's say 12 o'clock. So then we should see something at least, although the font is kind of small. We will be getting rid of this later. We just want to be sure that we can see everything. Alright, so after our layout, I would like the label to be center aligned horizontally. Here's how we can set that up. We will take our label, self.time label, call the set alignment method, access the class of Qt, access align center. This should center align our time. Now let's work on the font. I can barely read it. We will take our label, self.time label, set style sheet. We can pass in multiple CSS-like properties. Let's set the font size. I'll set it to be 150 pixels. Now we can read it. You could pick a font, but we're going to change that at the end of this video. We'll import a custom font. But temporarily, let's say font family Arial. You could change the color too. So if I set the color to be green, then the font color is going to be green. But I would like a very specific shade of green. You could always Google a color picker, then pick a very specific color. Let's go with that, something that's bright green. You can copy the hex value, RGB, or HSL. HSL means hue, saturation, and lightness. I'll use HSL values. For the color, we will type HSL, add a set of parentheses, then paste those values. But there is a degree symbol, you do have to get rid of that. Now the font color is going to be bright green. Let's change the background color. Here's how. We will take self, that applies to our clock, then call the set style sheet method, pass in a background color. We will set the background color property to be black. I think that looks pretty good, but it doesn't quite do anything quite yet. That's the next step. Let's create a method to update time. No arguments besides self. I will create a local variable of current time equals. Now to get the current time, we can access the class of QTime. QTime dot call the method of current time. We will need to convert it to a string. We will method chain the toString method. Within the toString method, we will design the layout of the time. So I would like hours first. I will type 2 H's, colon, minutes, that's 2 M's, colon, 2 S's. To set the text of the label, we will take self.timeLabel, call the setText method, then pass in our current time. So if I run this currently, we still have our placeholder time. Let's update it with the current time. We can get rid of our placeholder text of 12. We can delete it. After we set the font, let's call the method of update time. Self.updateTime. Now we should display the current time. So I'm recording this video at 7:44 in the morning. If you would like to add AM or PM after your time, here's how. After our string format specifiers, we will add capital AP. A means ante-meridiem, and P means post-meridiem. So then we should display AM or PM, depending on when you're coding this. Currently the time for me is 7:45 AM. To get the clock to update every second, we need to connect our timer widget to a slot of update time. We will take our timer, self.timer. This isn't the time label, it's the timer to keep track of the time. During a signal of time out, we will connect the following slot of self.updateTime. self.updateTime. With our timer, we need to trigger a timeout signal every 1000 milliseconds. Every second, that is. To handle that, we will take our timer, self.timer, call the start method, then pass in 1000 for 1000 milliseconds. So then, when we run this program, our clock should update every second and display the new current time. As an added bonus, if you would like to download a custom font, here's how. Using Google or another search engine, I would recommend looking up a font of your choosing. So one font that I like is DS Digital. What we need is a TTF file, meaning true type font. I'll just pick this first link. So these fonts are pretty good. So I'm going to download them. I'll pick this specific font, DS Digit, and again the file extension is TTF. So once you have your font, move it to your project folder. So for convenience, we have that TTF file right next to our main Python file. Okay, to work with specific fonts, we will need the following import from pyqt5.qt.gui import q font as well as q font data base. Since we're going to use our own custom font, we can delete that from the setStyleSheet method of our time label. So let's set the font right here. We will assign a local variable of font ID equals q font data base. QFont database is a class for managing and querying fonts available to the application. To add a custom font, we will call the following method within it: add application font. Within the set of quotes, we're going to pass in a file path. This can be a relative file path or an absolute file path. This TTF file is right next to my main Python file. I only need the file name. My font file is named DS Digit and get the file extension of TTF. We will create a local variable of font family. We will retrieve the name of the font family from this ID. Again, we will access qFontDatabase dot call the application font families method. So this method returns a list of font names. We will pass in our font ID, but there's another step. We're going to use the index of operator and get the index of 0. This will retrieve the first element of the font family. That's because we're working with a list. We will need just the first element at index 0. Now we'll have a font family to work with. Now to set the font, we will create a local variable of myFont equals call the class, call the constructor within the class qFont. Pass in the following arguments: our font family, that's the first argument, and then a font size, let's say 150. To set the font, we will take our time label, self.timeLabel, call the setFont method, then pass in myFont, our custom font. So then we should have our custom font, that digital font that we've downloaded. Alright everybody, so that is how to create a digital clock widget using PyQt5. Hey everybody, so in today's video we're going to create this stopwatch program using Python's PyQt5 library. Once that's out of the way, you will need the following imports. Import sys. Sys means system. It handles system variables for your Python interpreter. We will need the following widgets. From PyQt5, access the module of Qt widgets. Widgets are the building blocks of a PyQt5 application. We will import the following widgets: Q application, Q widget, Q label, Q push button, QV box layout, and QH box layout. Let me put these on a new line just so we can read everything. From the package of PyQt5, access Qt core. We will import QTimer. Our timer will emit a signal after a given interval, which is what we need for a stopwatch. QTime to keep track of the time, and Qt for alignment. Let's do a test run to be sure that there's no errors. Looks like L in label should be capital. There we go. No errors. Once you have the following imports, we will construct a class of stopwatch, which will inherit from the base class of QWidget. Our stopwatch will be a widget. We will need a constructor. We'll define that. Dunder init. No arguments besides self. If we have arguments to pass to the parent of QWidget, we will call the superclass the parent. Call the constructor of the parent. No arguments currently. Now, if we are running this file directly, we'll use an if statement to verify that. If dunder name is equal to a string of dunder main, if this is true, if we are running this file directly, then we will construct a stopwatch. We will create an app object, call the constructor within the Q application class, pass in the following: access sys, our system, access argv, which means arguments. This is if we're using command line arguments, which we won't be using, but it's nice to future-proof our code just in case we do in the future. We will create a stopwatch object. Stopwatch equals, call the constructor within our class of stopwatch. Our window is not going to show unless we call the show method. Take our stopwatch, call the show method. Now our window is only going to show for a brief second. We need to ensure a clean exit. We can access sys, call the exit method, pass in the following: app, then call the exec underscore method. This method starts the main event loop and handles events. So then we should have a basic window, which stays in place until we close it. We now have the main skeletal structure of a PyQt5 application set up. If you're one of the people that have jumped ahead up until this point, we have a class of stopwatch, which inherits from the QWidget class. We've constructed a stopwatch object, and we're showing it. So now we can begin designing our stopwatch. We will create a time object, self.time equals, call the constructor within the class of QTime. For arguments, we'll pass in the hours, minutes, seconds, and milliseconds, all 0. We need a label for the stopwatch. Self.time label equals, call the constructor of QLabel. What would we like the text to say? I'll display some placeholder text. A bunch of zeros. 0 hours, minutes, seconds, and milliseconds. We will add this label to self, our stopwatch. We need a start button, self.start button equals, call the constructor within QPushButton. What would we like the text of the button to say? Let's say start. We are adding this button to self, our stopwatch. We need a stop button. Let's replace start with stop. Change the text from start to stop. And reset. The name of this button will be the reset button. The text will be reset. We will need a timer to emit a signal at a given interval. Self.timer equals, call the constructor within the class QTimer. Then pass in self. We're going to call a method of initializeUI, self.initUI. But we still have to define this method. Alright, within our stopwatch class, we need the following methods. A method of initUI. This is where we'll be designing the user interface. I'll write pass for now as a placeholder. We need a method to start the stopwatch, that is. A method to stop the stopwatch. a method to reset the stopwatch. We'll create a method to format our time. Format time. Besides self, there's one parameter. We have to pass in a time to format. We will be returning a string representation of the current time, and a method to update our display. Update display. Here are the 6 methods we'll need. Within our initialize user interface method, we will set the title of the window, because right now it says Python. We will take self, our stopwatch, call the set window title method, and we will pass in stopwatch. That should change the title of the window to stopwatch. We're going to use a vertical layout manager for the label and the buttons. We will create a layout manager named vbox. Vbox equals, call the constructor of Q vbox layout. We will take our layout manager and add the following widgets. Self.timeLabel, then our start, stop, and reset buttons. Start button, stop button, and reset button. We will take self, set the layout, pass in our vertical layout manager. So we have all of our buttons. We have our widgets arranged in a column. We're going to take our time label and also center it horizontally. We will take our time label, self.timeLabel, call the set alignment method, access our class of Qt, access the flag of align center. That's going to center align the time. It should be aligned both vertically and horizontally. Now with your buttons, they're arranged in a column. We could group them together horizontally. Here's how. We will create a horizontal layout manager of hbox. Hbox equals, call the constructor of QHbox layout. Instead of adding these buttons directly to our vertical layout manager, let's cut them, paste them underneath hbox, replace vbox with hbox. Then with our vertical layout manager, vbox, we will add our layout of hbox. This group of buttons is arranged vertically with the time label. Now we'll be applying a style sheet. Access self, our stopwatch, call the set style sheet method. We can pass in one extremely long string with a set of triple quotes. All of the CSS-like properties we'll add will do so between the set of triple quotes. Let's select our buttons. Q push button. We are selecting an entire class. Within a set of curly braces, let's add the property of font size. The font size of all buttons will be 50 pixels. Let's customize our label. Select the class of QLabel. Within a set of curly braces, let's add the following properties. Font size will be 120. If you would like, we can add a background color too to the label. We can select a background color. Temporarily, I will select blue, but we can pick more specific shades of blue or another color. Here's how. You can look up a color picker and select a very specific color. You can use hex values, RGB, or HSL. I've already selected a color. I'm going to copy these HSL values. So instead of a color name, we will select HSL, then paste those values. If you have a degree symbol, you will need to remove that. And now we have a very specific shade of blue. I will also round the corners of our label. add the property of border radius. I will set that to be 20 pixels. This will round the corners. Between each button and label, we'll add some padding. We're going to use multiple selectors,